Hello everyone, my name is Aaron Standard and I'm the CEO and founder of Petabridge. Today I want to talk you through how to install Phobos 1.0 into your own Akka.NET applications so you can observe and monitor how well your applications perform at runtime. Now, in the context of observability, Phobos does two different things for your applications: tracing and metrics. Tracing is how we visualize the activity that occurs in a software system, and we're trying to ultimately tell the story of how each request got processed. And that might include that request passing through multiple different types of services. So, for instance, you might have the request originally enter the system in the form of an HTTP request, or maybe through a queuing system like RabbitMQ. That request might in turn be handled by an Akka.NET cluster, and the response might be served back over HTTP or Rabbit. Tracing is designed to end-to-end connect all those different little pieces together into one coherent story. And this is all done with the intention of drastically lowering our debugging and troubleshooting costs. Now, the second type of observability that Phobos provides for Akka.NET applications is metrics, the ability to quantify Akka.NET activity in the context of a live running application. And these include built-in metrics such as actor starts and stops, message processing throughput, the number of crashes and errors that were observed over a period of time. And that's really what metrics are all about. Being able to tell a story of how much of activity X occurred over duration Y. And this technology is used to power alerting and resource monitoring, which are necessary components for any type of high availability application that any company in any industry might want to build. So the way Phobos ultimately works is Phobos is a library that offers a degree of telemetry, and this telemetry gets automatically injected behind the scenes inside your Akka.NET application. So you don't need to worry about decorating any of your individual actor classes with specific method calls or anything else. Phobos will inject the monitoring instrumentation for gathering traces and metrics automatically into each of your actors. The data captured by Phobos will automatically be exported out to the tracing and metric services of your choice. So Phobos is pretty extensible. It'll work with a large range of different APM tools. So for instance, we work with commercial cloud-hosted solutions such as Datadog or Azure Application Insights. We also work with off-the-shelf open source solutions such as Jaeger for tracing and Prometheus for metrics. And in fact, in this tutorial, we're going to be showing how to take an existing Akka.NET plus ASP.NET application, and we're going to be showing how to integrate it with Jaeger and Prometheus using Phobos 1.0. Now, the first thing we're going to want to go ahead and do if we're going to work with Phobos is we're going to want to go ahead and buy a license for it. Phobos does not offer free trials, but you do get a 30-day money-back guarantee. So you can go to this URL at SDK bin, or you can just click on Browse Products, and you can see Phobos here in the product listing. If you drill through here, you can go ahead and see some links to the Phobos Quick Start tutorial, which is what we're going to install Phobos into today. You can also access Phobos' very detailed documentation website here, which includes a number of other different tutorials and concept sort of overviews explaining how configuration works and installation. You can find all that there. But in order for us to actually work with Phobos, we need to have access to a Phobos NuGet feed, which you can buy right here via credit card. In our case, I'm going to go ahead and use our Phobos dev server, and I'm going to go ahead and get access to my Phobos license key right here, which is what I'm going to need to go ahead and add into our NuGet.config that we're going to use to get access to the Phobos packages we want to go ahead and install inside our Akka.NET application. And you can see an example of what a complete NuGet.config might look like right here inside the SDK bin installation page. So I'm going to go ahead and copy this. And then we're going to install it inside our NuGet.config for the solution that we're going to clone. Now, the project that we're going to install Phobos inside of is a public repository. This is the Phobos Quick Start tutorial, which we link to pretty prominently off of the Phobos website. We're going to go ahead and clone this, and we're going to install Phobos into this solution. And we're also going to install the Jaeger and Prometheus drivers we need for Phobos to be able to export and render all of its metrics. So I've already taken the trouble of cloning this down onto my local system. And I'm going to go ahead and grab the NuGet.config file, which you can see right here. It's usually in the same folder as the solution file. And I'm going to go ahead and paste that line I copied from SDK bin. And this should give my project the ability to go ahead and install Phobos packages directly from SDK bin now. Now that we've added our Phobos key to NuGet.config, we can go ahead and go to the petabridge.phobos.web.cs project file right here. And we can go ahead and install all of the different NuGet packages we're going to need to instrument this ASP.NET Core plus Akka.NET application. So we're going to go ahead and install phobos.actor.cluster. So if you're using Akka.cluster in combination with Phobos, this is going to be the library you want to use. So we're going to install that first. Next, we're going to install the OpenTracing.contrib.NET Core library. This allows us to go ahead and trace activity that's occurring inside the ASP.NET and .NET Core base class libraries. So we want to have this in place so we can correlate activity that's being generated by ASP.NET and follow it all the way through into our Akka.NET cluster. And then finally, we want to install the driver for Jaeger. This is going to allow us to actually trace the activity and report it to the Jaeger Kubernetes pod that we're going to start. And that's going to let us visualize the activity that's going to be occurring inside our application. And then down here, you'll notice that I'm installing a number of App.Metrics packages. These are all part of the App.Metrics library, which Phobos 1.0 uses. And App.Metrics is kind of a standardized library in .NET Core for being able to export metrics from .NET applications to any number of different monitoring backends. It supports Datadog, Application Insights, Prometheus, InfluxDB, Grafana Cloud, Graphite. I think I might have already mentioned that. But we need to install a number of packages in order to get all the data we want out of App.Metrics. So we want to install the App.Metrics.ASP.NET Core package. We want to install the App.Metrics.formatters.prometheus package. And then if you want to go ahead and get data out in the console as well, you might want to install that package too. So with all of these installed, we should be ready to actually begin instrumenting our application. All right, so now that we've installed all of our NuGet dependencies we need to build a fully instrumented Akka.NET application using Phobos, let's go to startup.cs and wire everything together. So I have a number of different methods here in our startup class that are stubbed out. One for configuring metrics, another for configuring tracing, and then a third one for configuring our actor system. At the moment, this is all running just using vanilla Akka.NET and ASP.NET Core. And we're running Akka.NET behind the scenes as a hosted service here, by the way, which is kind of a standard best practice for using Akka.NET in the context of a web application. So in order for us to go ahead and get really precise and detailed tracing and metrics information, we need to do a couple of things. The first thing I'm going to do is I'm going to go ahead and add support for tracing ASP.NET Core using the OpenTracing.NET.contrib library. So what this is going to do is this is going to wire into the ASP.NET Core middleware, and every time we receive an HTTP request of any kind, we're going to go ahead and label the name of the operation as it's going to appear inside Jaeger as the combination of the HTTP method and the path. So if I go ahead and request, let's say, the about page, that'll show up as get/about, and that'll appear inside the little tracing log viewer area of Jaeger. So I'm going to set that up first. This is just using a couple of extension methods provided by that OpenTracing library. Now, the next thing I'm going to go ahead and do is I'm going to configure App.Metrics to use Prometheus. So I'm going to go ahead and grab my code for that and paste it in here. I'm going to try to indent it. This is doing a few different things. The first is we're going to add some metrics tracking middleware. This is going to record metrics that are specific to ASP.NET Core, and it's going to expose them inside App.Metrics as well. And then on top of that, I'm going to go and configure our metrics collection here, where I'm going to specify that the name of this particular service is going to be equal to its host name, that the default context in which our metrics are being recorded is all Akka.NET, and we're going to go ahead and basically say that our metrics are enabled and we are reporting them. And I'm going to specify that we're going to output our metrics as Prometheus plain text. Now, if you're not familiar with Prometheus, the way Prometheus works is that its metrics all get exposed on a HTTP endpoint. Usually it's the /metrics route. And those metrics will periodically be queried by Prometheus and scraped. And that data will all be ingested into a little time series database that Prometheus uses. So we're just specifying the Prometheus sort of data format here, that we're going to use the text format that Prometheus is famous for. And then finally, we're going to start up a little hosted service behind the scenes, and this ships as part of App.Metrics. And this is going to occasionally tabulate all the metric totals that are being aggregated. That way, we don't have as much data that needs to be scraped each time, and the operation can be completed that much more quickly. So this is all we need to do to go ahead and set up Prometheus. We just need to grab our metrics, and we need to register everything with our dependency injection container right here. Now, next, we're going to go ahead and configure Jaeger. This takes a little bit more work because we actually have to push our metrics out to Jaeger rather than waiting for Jaeger to come and scrape it from us, which is what we're able to do with Prometheus. So I'm going to go ahead and try to fix my tabbing here to the extent that I can. So with Jaeger, we're going to go ahead and use some environment variables that I specified up here, the agent host and agent port. And we're going to go ahead and transmit using the UDP or the HTTP sender. We're going to go ahead and transmit to Jaeger the output of all the different traces that we're building. And we're going to go ahead and say, all right, we're going to name the service after the assembly that we're executing. So we're going to go ahead and say this service is going to be named after petabridge.phobos.web. And we're going to go ahead and grab this reporter. We're going to go ahead and grab a sampler here. This constant sampler means that everything's going to be included in the sample. In really busy systems, you might want to go ahead and use one of the probabilistic samplers, which will only include a percentage of all the traces built by your system. Jaeger has a lot of really nice options and tools for that. And the last thing we're going to include is this scope manager right here. The actor scope manager is specific to Phobos, and this makes it really easy for Phobos to correctly correlate activity that happens inside the actor system with activity that happens outside the actor system. So if you forget to include the actor scope manager, your traces might look a little funny. So always make sure you pass this in when you use Jaeger. We also have an extension method you can use on any of the tracers that implement the iTracer interface from OpenTracing. We can just call with scope manager, and you can pass this in here, and Phobos will automatically wrap that OpenTracing tracer and make it available for you. You need to do that inside libraries like Datadog, for instance. Okay, so that should be good to go. So now we have our tracer, we have our metrics. Now we just need to integrate everything inside Akka.net. So what we're doing at the moment with Akka.net is we're wrapping our actor system and the handful of actors that we use inside this little Akka actors class right here, which is, if I scroll down, just a simple class that contains the actor system and a handful of actor references. Well, the way we're configuring the actor system currently is we're creating this bootstrap setup here, which is going to go ahead and contain the HOCON configuration that we're parsing from this file. We're also injecting some environment variables from Docker in here as well. Well, we're going to need to go ahead and merge this setup structure with the Phobos setup, which is something that's introduced by the Phobos library. So the first thing I'm going to do is we're going to go ahead and use the ASP.NET Core dependency injection to grab a hold of the iMetrics root. This is the App.Metrics root class. This is where all the metrics come from that we want to use for keeping track of how well our system's performing. And then we're also going to grab a hold of the iTracer, which is the type that gets returned right down here when we call tracer.build on the Jaeger library. We need both of these to populate Phobos. Next, we're going to go ahead and create a Phobos setup. So I'm going to go ahead and grab a reference to that right here. And I'm going to go ahead and try to make this look nice. We have our Phobos setup with metrics and with tracing. And I think that should be everything that we need. And then finally, we need to go ahead and merge the Phobos setup with the Bootstrap setup. Although there's one more thing we need to do, which is that I need to tell the Bootstrap setup that we want to go ahead and use the Phobos actor selection provider. The Phobos actor ref provider right here. This is going to be what actually is responsible for injecting all of the Phobos telemetry behind the scenes is this line right here. This is what turns Phobos on. And as a result of this running inside your actor system, all of your actors will automatically be instrumented without you needing to write any code yourself. So this line is pretty important. Now that we have access to our metrics and we have access to our tracer, we need to go ahead and merge our setups together into what's called an actor system setup, which we can do by calling Phobos setup dot with setup. And I'm going to pass in our bootstrap setup like this. And I can pass this into my actor system setup below. So now that our Phobos setup and our bootstrap setup are both merged together into a single setup class, and that's been passed into our actor system, we are now ready to start our Akka.NET application with Phobos in hand here. And we're going to go ahead and use our little command line to build a Docker image that has this version of the petabridge.phobos.web solution code inside of it. Now, the way we're going to run this particular sample is we're actually going to go ahead and deploy everything into a little local Kubernetes cluster that's going to go ahead and run directly on my development PC here. So we're going to go ahead and deploy our Akka.NET plus ASP.NET application as a stateful set in Kubernetes here. We're going to go ahead and set up some routes for being able to receive HTTP traffic over port 1880. And then we're also going to set up some ports for being able to receive Akka.NET traffic privately on port 4055. We're going to create 3 replicas of the service, so 3 nodes total. We're going to go ahead and use this version of this locally built Docker image that we're creating. And you can see some of the environment variables we're passing in for things like our seed nodes for Akka.NET cluster, and then some of our information about where the Jaeger agent service lives. So we're going to set all of this up. In addition to that, we're also going to deploy Prometheus. So we're going to go ahead and deploy Prometheus into our cluster. We're going to deploy Jaeger using their all-in-one Docker image. So this is kind of meant for test driving Jaeger. And then we're also going to deploy Grafana, which is a dashboard and visualization tool for APM services. We're going to go ahead and deploy Grafana inside our cluster as well. And we're even going to include some default dashboards that are used for visualizing of Phobos, Akka.NET metrics, as well as ASP.NET Core metrics, and even some Kubernetes metrics. All of these dashboards will be loaded automatically into our Grafana instance once it starts. And all the data from Prometheus will be pre-populated into Grafana without us needing to do anything. So to go ahead and launch our Kubernetes cluster, let's go ahead and double check. Looks like our Docker image was built successfully. We're going to go ahead and go to the Kates folder and hit this command here, deploy all. This will go ahead and create a brand new Phobos namespace in Kubernetes, which you can get access to. Get all -n, and then Phobos Web. It's going to be the name of our little namespace here. Now I've already had my cluster running for a period of time here. So we can go ahead and see what some of the data being produced by Phobos might look like. All right, so we have our local Kubernetes cluster deployed. Just for the sake of convenience, I've scrolled back to our GitHub repository where our code sample is. And if you scroll down to the bottom, we have some hyperlinks that show us where are all of these services hosted in a way that we can access them from our web browser. So in this case, I'm going to click on localhost 1880. This is our actual application we've installed Phobos and OpenTracing and App.Metrics into. And each time I go ahead and reload this page, it's going to generate a new series of interactions that are all going to be captured by Phobos. And so we can also click into the Jaeger user interface here, and we can see the petabridge.phobos.web service. And if I scroll through the list of operations, we can see some of these operations recorded by Phobos, an Akka.NET actor receiving a string or an info level log message. And we can also see some HTTP requests getting logged. So if I go ahead and click Find Trace, I can see a bunch of different distinct operations. Each one of these correlates to one HTTP request where I tried to access the root part of our website using a GET request. If I drill into this, we can see that it took about 57 milliseconds for this operation to complete, and that our get operation was originally received by Phobos Web 1, which is one of our 3 instances running inside our Kubernetes cluster. And then from there, we went ahead and created another little sub operation here. This cluster.ask operation is something that I generated manually inside our ASP.NET Core application by calling our OpenTracing iTracer. Let me scroll down a bit here. So we go ahead and specify our HTTP route handler right here. I'm going to grab our tracer from ASP.NET Core's dependency injection, and I'm going to go ahead and use the tracer to create a custom operation that I'm going to go ahead and record as active. So that operation will automatically be marked as completed inside Jaeger when this using block exits. And then we're going to go ahead and ask our Akka.NET router forwarder actor right here for a string. Once we get that response back from the Akka.NET cluster here, this router forwarder actor is actually going to forward this message inside the Akka.NET cluster using a cluster group router. Once that message gets handled by an actor somewhere inside our cluster, we're going to write that response back out to the HTTP output stream. And that is exactly what we can see happening right here. We can go ahead and see that one of these actors originally received a string. We also recorded a little, let's say, log message here. So we've recorded this little info level log message. Then we can also see that another actor running on a totally different node inside the cluster, in this case Phobos 1.0, also received this string. And then we sent a reply back, and then we went ahead and actually completed the operation. And that's what allowed this original GET request to get served. Now, one last thing I want to point out is if I go back and take a look at our actual actor implementation code inside here, you'll notice that this actor that we've implemented here, our router forwarder, and our console actor really do not have anything in terms of explicit implementation that we had to add in order to record those strings that we received. These messages the actors receive here are all automatically recorded via Phobos. However, if I want to manually record some additional metrics or some additional traces, you can do that through the context.getInstrumentation call, where I can access the monitor. So in this case, I'm going to go ahead and record a new timer to go ahead and measure processing time for this message. So this data will show up inside Prometheus. And then I'm also going to go ahead and record programmatically another span using the same tracer that we used inside ASP.NET to go ahead and record that custom operation down here. This method allows me to go ahead and access the tracer that was passed into Phobos, this context.getInstrumentation call. And I can use that to build a span, start it as active, and any log events that are recorded while this span is open will be automatically appended to that span inside. So if I go down here to second up, you'll see this little log message right here. Any of those events that are recorded while the span is active will all automatically have their logs and everything else appended to them here. So that's the Phobos tracing functionality in a nutshell. The next thing we're going to take a look at is the metrics and what that looks like inside Prometheus and inside Grafana. Okay, now I'm back at our README for petabridge.phobos.web again, and in this instance, I'm going to go ahead and pull up Grafana, which is running on localhost 3000. Grafana always requires a username and password, so the default is admin and admin. So we're going to go ahead and log in. I'll skip that. And you'll see we have a couple of default dashboards that are already installed into Grafana. The first one we'll take a look at is the Akka.NET metrics that are gathered by Phobos. So you can see here in the last 5 minutes, we've had a steady stream of, let's say, message processing here. So we're processing on the order of, looks like about a message per second on average. We're using the Kubernetes health check to generate some traffic. And we can go ahead and see over the past hour that this application has been running. We've recorded 20,000 strings handled by the router forwarder actor and 20,000 strings handled by the console actor. We've also seen in the neighborhood of 40,000 info level logs be recorded by petabridge.command. This is kind of a little overview of how actors might be producing information based on some of the data that's being automatically captured by Phobos, and it's being scraped by Prometheus. Now, if we want to go and add new charts and dashboards to Grafana, we can go ahead and query some additional data from Prometheus here. Or if I go ahead and start spelling out the name of some of the different metrics that are being exported, I can take a look at the number of dead letters, for instance. So if I execute that, and we can go ahead and see that we've seen some dead letters in the neighborhood of 10 of them come from this Phobos Web 0 node, and it was all internal cluster join messages. So these were dead letters that occurred during the process of a cluster forming, and we can see some of that on Phobos Web 1 as well. So we can go ahead and get metrics like that. We can go ahead and get a look at some of our logs. So if I go ahead and execute this, we can take a look at the number of info and warning logs that have been recorded by Phobos, and we can use this data and the Grafana query builder to go ahead and construct a new graph inside our dashboard if we wanted. So this is an example of some of the metrics that are being produced from Phobos, and this is all automatically being recorded and captured inside Prometheus. And we can go ahead and use Grafana to model all sorts of things, live dashboards. It's pretty easy to set up alerts as well if you want. You can set some alert rules and add notification channels. And this is an example of kind of do-it-yourself open source approach for using a tracing plus a metrics tool for being able to get observability into how well your Akka.NET application is working. Phobos is also compatible with lots of cloud-hosted APM platforms such as Datadog, Azure Application Insights. Even Grafana's own cloud is another service that Phobos can work with. So with that being said, thank you very much for listening today. If you have any questions, please go ahead and take a look at our contact form on petabridge.phobos.com. You'll be able to find some ways to get in touch with there. Please let us know if you have any questions or run into any difficulty getting Phobos installed. Also, remember that your Phobos license does come with support, so if you need some help getting Phobos up and running in your company's environment, you always have the ability to reach out and contact us and get some hands-on help from our development team here at Petabridge. So thank you very much for your time today, and we look forward to helping you successfully monitor and observe your Akka.NET applications using Phobos.